Welcome everybody to the second installment of automating your manufacturing CAM system here with Janus Engineering and AMS. Today we're going to be highlighting the Janus Engineering speed mill application, which helps us automate 2.5 axis programming, as well as showing off some really neat tips and tricks from our colleague Henrik Flon out of Germany on how to properly set up CAM to help automate your programming going into the future. So for some of you that are new to us, we are AMS Inc. and Janus North America. So if you're not familiar with Janus North America, Janus Engineering is the leader in NX CAM globally, and as well as a direct partner with Siemens as far as future development is concerned, and partners with on a global status with Siemens. Here with AMS, we've been involved with Janus Engineering now for 3+ years and have recently been fully partnered and are Janus North America here in the United States. So we focus on everything from the Janus extensions right down to training, post-processors, machine kits, and custom applications for our customers. So today we're going to talk about a few different topics here, one of them being Speed Mill. Speed Mill is a very powerful automation platform within inside of NX CAM that helps automate all of our 2.5 axis programming. Today we're going to focus a lot on hole geometry because in most parts I think something like 40% of all program geometry happens to be holes. So how can we simplify that process and really make it easy for programmers to increase their throughput, and of course keeping best shot practices while doing so. And then we're going to follow up with Henry from Germany. Henry's going to show us some really trick CAM setups to help us enable to swap parts, swap fixtures, and program any part from any existing program. And finally, we'll follow it up with a little review and a questions situation. So we're going to keep the questions to a minimum until the end, and then we'll be more than willing to answer any questions that you may have as it relates to this webinar. A little bit about ourselves. So here in the U.S., we like to take the wizard approach. So you can see, as we call Henry, he's the samurai here of knowledge with NX. Myself, I've been working within the PLM systems for 20+ years. As well as manufacturing parts almost my entire life. So we're excited to show you what we have to offer here. So going into some of the critical issues of current NC programming, as you all know, programming is click intensive. It can take 10, 15, 20, 30 clicks just to get an operation out the door. And then of course we have limited reuse with those operations and all those previous clicks we had. Of course, in NX, we have the ability to copy and paste, but we still have to reselect geometry, which somewhat allows us to use current configurations within the operations. All of this leads up to a lack of best shot practices. So how do we standardize feeds and speeds, depths of cuts for different tools, and of course, material-based. And then also there's tool creation. Another process-driven task within inside of NX is creating tools. Now, we also have the internal library, but for some of you out there, you're using the highly technical technology manager that we would encourage all of you to take a look at going into the future, and you can check it out on our YouTube page for the automator. And of course, minimal throughput with all of these tasks at hand and no intelligence in our programming going into the future. So how do we automate some of these solutions? One of them is using feature-based geometry inside of NX, which can be very complicated and heavy. Another one is using the Janus Speed Mill product. So as we're going to show you in the upcoming demonstration, Speed Mill is a very easy to use automation solution for programming. Minimal clicks, and of course, increased throughput in our programming, which is going to increase our throughput on the shop floor. So let's make every part more cost effective. Of course, Speed Mill is a self-learning software that can automate all of our 2.5x programming, right down from holes to pockets, tapping, thread milling, you name it. 2.5 axis, Speed Mill can handle it. Of course, with SpeedMill, we have automatic geometry recognition, and of course, referencing previously generated toolpaths and reusing those toolpaths for future projects. It's a very simply used interface. We can learn SpeedMill in a matter of maybe a half of a day or less, and of course, going forward with SpeedMill requires using it on a regular basis to continue to build our database of geometry and processes that we use. And of course, reduce the errors at the machine, breaking tools, running tools too fast, too slow, and really optimizing the entire process for us. And of course, standardizing those shop practices across all the programmers. All right, now to jump into NX here. So to give you an idea of what our workflow is going to be today and showing off SpeedMill, we've created 3 different parts for you. And the idea is to understand the process from start to finish and finally execute the entire program. So as you can see, we've had some operations created here already in part 1, in part 2, and in part 3 here. So part 3, we're going to apply all the operations that we learned from part 1 and part 2 right to part 3 and pretty much program the whole part for us. So we're going to open up SpeedMill and take a look at the user interface. Here you can see our SpeedMill application. It flawlessly integrates into the NX solution. Taking a look right now at our database, you can see that we have an empty database in this situation. As typically we would have a filled database if we were a manufacturer, but we want to kind of show you the start to finish process and how things fill up. And of course, we have our ability to change some settings in here, and we can see all the templates from NX that SpeedMill uses. And of course, some additional operation parameters here for milling and drilling, and we can have some tolerances as far as how we look at holes and then apply them to future projects. And finally, we have a little bit of a utility that helps us create colors and surfaces, find different diameters, as well as have attributes associated with these features. So let's get started here. So here you can see we have a bunch of operations on this part. Now the power of SpeedMill here is using previously generated operations, learning those operations, then recognizing those features on future parts. So in this case, you can see we're using it right now for a lot of hole making. So here we can go in here, we can select all of our operations. And it's as easy as just saying teach. So we're going to teach our operations now, and it's going to open up the SpeedMill dialog box, and you can see here are the operations that we have taught. On the right-hand side, you can see the attributes associated with these operations. Now, of course, we have the ability to control additional attributes, including color, face name, PMI, and more. It just really depends on how we want to control our features. For example, some customers decide to make quarter 20 holes a certain red. So every time that red appears in the part, it'll know it's a quarter 20 hole and follow our best shot practices to make it happen in the programming process. So we're going to save this, insert this into our SpeedMill library, and then we're going to take a look at part 2. Part 2 is the same thing, except notice how we only have 5 operations here. So we're going to go in here and do the same thing and teach part 2. And you can see here, 3 of the operations are already recognized from the previous part. So there's only 2 open operations that are going to be added to our database. Now, the really neat thing about this part is that watch now we went from 5 operations, and we're going to delete these. And we're going to program additional features on this part. All right, so now we're going to say, come in here, and it's as easy as just saying, apply these previously generated operations to this part. SpeedMill works quickly to understand our part geometry. And quickly you can see now we have programmed more features than just the original 5. So we can come in here and we'll generate these operations. Now, as you can see here, it would have taken us, maybe a half an hour or so to program all these features or more. And with the speed mill, we were able to accomplish the same goal within minutes. Of course, increasing our throughput for every part that we make and eliminating those tedious tasks that we have, like making holes. Every part we make has holes, so why not limit the amount of programming we have to do and just take care of it right up front with speed mill. So as you can see now, we generate a toolpath for all of our components, all of our features on our part, and program those features. As you can see, SpeedMill is a very powerful tool to help automate your programming. Now, for the really cool part. So as you can see, these two parts are quite a bit different in features and look. We're going to go to a much larger part now, and to give you an idea how large this part is, I put it on a DMU 125 here for us for reference. So that's a 1200 millimeter table, so roughly that part is maybe 800 millimeters in diameter or something like that. So how can we take a part that has no previous history and end up programming all of these unique features throughout? Well, using previously generated geometry and SpeedMill, we can easily accomplish this task. So all we're going to do here is we're going to say pattern recognition. We're going to select this body here, and we're going to hit OK, and we're going to watch SpeedMill program all of these features on this part. Now, these features were created from previously generated operations in part 1 and 2. This is just going to take a few minutes, but as you can imagine, if we're going to do this by the click process, it might take us a day to program all of these features within inside of NX. And of course, using our best shot practices and current knowledge we have about the operations and tools we're using, we're able to get the best outcome at the machine. Now, I'm sure many of you out there struggle with the click situation, and of course, 2.5D, whether it's simple pockets or creating hole geometry, tap threaded holes, whatever it may be, we can control all of these parameters within inside of SpeedMill to help simplify your programming. And SpeedMill is a very cost-effective way for us to standardize these practices throughout all of our programming staff in our shop. SpeedMill also works flawlessly with either the internal NX library, which allows us to pull previously created tools, or in applications such as Technology Manager, where we can pull tools directly from Technology Manager, automatically apply feeds and speeds based upon materials, and even machine geometry, for that matter. So as you can see, we've created operations now for all of the features on this part based upon our first two part geometries. So let's quickly generate these operations. Now, what we've just did in a matter of minutes, like I said, would take the good part of a day to accomplish. So you can imagine the increased throughput from the programmer side, and of course, also the increased throughput at the machine as we're standardizing these best shot practices and optimizing feeds and speeds throughout our programming process. Of course, we can come up here and verify. Let's do 3D dynamic here. And you can see how easy it was for us to create this complex featured part in a matter of minutes using previously generated operations. And of course, as we build our database up and standardize our processes and how we use SpeedMill, we can more effectively program additional features within inside of NX. This was a short presentation for SpeedMill, and I want you guys to reach out to us so we can grow with this, but I want to leave as much time as possible for our friend Henry, who's going to really show you some mind-blowing processes within inside of NX that I think will get your attention. So without any further notice, I want to hand over the mic to Henry and let him show us his magic with NX.
All right, thank you for that. Okay, there we go. I hope you can see my screen.
We can see you.
Okay, very good. Good. Thank you for the invitation. Thank you for having me. Well, how can we improve our working within our daily business with an X? Let me show it to you by having an example like this here, okay? That is a part that I like to manufacture. My supervisor tells me each day what I have to do. And in this day, today, I have to manufacture that part in here. Well, how do I proceed? What is my daily workflow within NX CAM? Well, first of all, I have created myself a favorite tab. When I open it up, I see some templates in it already existing. For instance, a turning template, or even better, in our case, a milling template. Let me open it up. Once the template is opened, we see another part already clamped in vices, and those vices are already positioned on a milling machine. In my case, it's a DMG machine. When I zoom in a little bit, I see that the part is not clamped in this air space in here. When I can show you my blank material, we see that the part is being clamped correctly accordingly on the vices. Well, that's the first shot. Well, but I do have to manufacture that part in the first place. That's actually my task today. How do I proceed? First of all, I'm opening up the part that was being clamped previously. So that's my reference part. Let's call it like that. By making a right click on the part, maybe I can show you the blank material first as well. By making a right click on the part, I have the possibility to replace the component. With what part do I want to replace it? I will replace it with the very new part that I have to manufacture. By clicking on the OK icon, I see now that both of those geometries, the old and the new one, are being placed within each other. First of all, I will position the very new part on its rough position, how it's supposed to be on the machines, that, just by turning it by 90 degrees. And now I will get into my wavelink. By using the wavelink that is quite often used in an X, I have the possibility to get the knowledge from the old part to a new part. For instance, that face is supposed to be on that side of the very new part. That face is supposed to be on here. This top face is supposed to be up here, and so on. What I'm doing now is I'm selecting, or usually I am creating some, let's call it basic faces on the part. For instance, the extreme faces, the longest, the highest, the widest faces will be replaced by me. And by doing so, I am reassigning the intelligence from the old part on the new one. By clicking on OK, and the second time when I click on OK, I have to ask you to figure out how the blank material once looked like. It had the dimension of the first reference part. But when I click on OK, we see that the blank part has updated itself automatically. I did not change it. It updated automatically. Not just the blank part, but also my clamp situation. When I switch back to my cam setup, I see that the blank part got bigger. Therefore, those mobile vices of my fixture also moved accordingly. So that's for the positioning of the part. What else do I have? Can I see on here? When I take a look at my operation navigator, I see that my previous operations, for instance, the face top operation, is now outdated. I have to update it first. But by clicking on it once, I also see my old outdated tool passes. They were going right through the part. That's not correct in this case. By making a right click on it and generate, we will see that the operation, for instance, face top in here, is being updated automatically. I don't have to do anything at all. by making a right click on the rough outside operation and generate it. We will see that the operation is being updated automatically as well. Well, this procedure goes on for all the other operations as well. For instance, my previous part have had only one pocket in it. This part has 4 of them. How do I handle them? First of all, I'm having already a so-called manufacturing set existing in here. All those settings are already set by using the replacement assistant within the workpiece, within the wavelink. By making a right click on it and generate, we see that all operations are being updated accordingly to the new parts geometry. What else we can see? We see that this part has some holes in it, not like my reference part. How do I handle that? Well, just like Tim has shown us, I will start speed mill, and speed mill will search for already known geometries in this part. As we see, this part contains like 3 geometries that need to be drilled. By clicking on apply, all those operations will be created automatically according to their parts geometry, or better said, features geometry. Same goes for me as well, just like for Tim as well. I don't have to search for the geometries. SpeedMill does it for me. I don't have to select any kind of tools. SpeedMill does it for me. I don't have to define how to manufacture those geometries. SpeedMill does it for me. Well, and there we go. Now we have created a lot of diameter 8 holes in it. Right click and generate on them. There we go. Everything got spot drilled and everything got drilled as well. Well, what else we see? We see that this part contains some freeform geometries in it. For instance, let me show it like this better maybe. There are some freeform faces on that part that my previous part did not contain, or my template part did not contain. How do I proceed in here? For this, I also will use another manufacturing set. I'm just making a right click, insert. I want to insert a geometry as I, as a human being, have recognized a geometry in here. In my templates, I have the possibility to select a free form. And then here it's also already tells me select all faces for 3-axis copy milling. Okay, so let's do that. Apply with OK. Go to specify cut area. Now it told me to select all those faces that need to be copy milled. And I'm selecting the radii that I want to have. Select OK. Once more on OK. And now I have added a new container accordingly as I have decided to. When I open it up, I see I do have a freeform roughing operation with an tool selected, with feeds and speed already set, and so on. I just will make a right click on the operation and generate the toolpath. The freeform area is now being roughed by the system. Right click on the freeform finish operation, generate, and the freeform is also being manufactured. I can verify the toolpath by clicking on the toolpaths itself to see that everything looks smooth and fine. Okay, so actually the whole part is now finished for programming. I will just close up SpeedMill, need for that any longer. I will rearrange my operations that got created and regenerate the whole CAM program once more, because I'm still missing some of those other operations. While the system is being updated to the current geometry of the part, we also can think about the possibilities. What else is possible for that? The parts that I'm manufacturing can have any geometry. I it doesn't matter if it's rectangular, it doesn't matter if it's a ball geometry whatsoever. The procedure for me is always the same. I'm just regenerating all the tool passes that are already existing. If there are some new geometries that my reference part did not contain, I'm adding them by using those manufacturing sets. And for everything else, I'm using speed mill. For instance, the holes that we just have met in here. And once the generation of those operations is done, we will start the machine simulation as well to see how the machine behaves, how the post-processor is creating the NC code. That I'm just starting the CSE simulation. The post-processor begins to generate the NC code for that whole CAM program. Once it's finished, we will see on the right side the NC code. There it is. That's the NC code that will be simulated now. And when I click on the play icon, the simulation will begin. Maybe a little bit slower to see how the machine behaves. Okay, that might be a little bit too slow. Give it a little shot to speed up a little bit. Okay, well, so now as we have seen, I'm quite able to generate, to manufacture or to program a part that looks quite similar to my previous part. We have seen it's been a rectangle part, I've had some pockets in it and so on. But what happens if I have to manufacture another part? Just give me a quick second and I want to manufacture that part as well. There we go. So that's the next part that I have to manufacture now. What is my procedure now? Just like before, I will open up the part that I'm having clamped for now, and I want to replace the old one with the new one. Just like before, say it what I want to have. Click on OK. I'm rearranging the part's location a little bit so I have a better view of the orientation of the part, like so. Let's kick the wavelength once more. And now let's reassign some similar faces, some extreme faces, for instance, the highest, the lowest, the most right face, and so on. Also the slot geometry in here. That one goes there, and the pocket shall be here. What else we've got? Yeah, we have some other in here. And I want those faces here to be 3D copy milled. For this, I'm taking this radio face and select it in here, that radio face selected there somewhere, and something like that. I don't have to reassign all of those faces, just some of them. By clicking on OK and OK, we see that the blank material once more has updated itself. When we return to our setup, we see that the part got replaced with the new geometry. Well, so far so good, but what I don't like in this case is the vice that is being used for that small part. I want to have a smaller one. I want to have a, for instance, a 5-axis vice, not a double vice like this here. For this, I'm having some user expressions. So let's say the clamp situation is not to be supposed like number 2. I want to have number 1 in it. By doing so, my clamping device will be replaced automatically. Now I'm having another clamping device in here. But the part seems to be floating in the air above. Well, how come? First of all, I have another user expression that's called stop X. That's the user expression, that's the stop distance from this face, from this red face on the device to the part's face. By reducing that to like minus 30 millimeter, we see that the part is moving accordingly. And yet the part seems to be in the air. Well, There's a third expression that's called clamping height. For now, it's set to be 35 millimeters. When I reduce it down to 0, I see that the part now is on its right position. Let me show you the blank material once more. There we go. We see the clamping height is down to 0 and those vices are on their correct place. Okay, but what about our operations? Let's take another look. We remember that the face top milling operation seemed to look like that. By making a right click on it, generate, we see that the operation is being updated. Now we are on the right place, we can start the verification. For instance, also the 3D dynamic. There we go. Face top is done. Roughing outside is no longer necessary as I will use my freeform operation for that. So right click on it and delete. Pockets rough, what about that? Remember, I do have a manufacturing set for that. It's called pockets. Double clicking on it, I see that the floor is already, or the bottom is already selected. I just have to add another trim boundary in it. And the trim boundary will be around this face by saying okay. Okay. I can also check out the slots geometry. Previously, it's been in this cross manner, but now I have the circle only. Right click on the slot, generate. Here we go. So now I do have some drilling operations left, like the diameter 8, 6, 10, and the second 10 diameter. Just make a right click on it, delete, gone. Let's return to the freeform. I have to specify the cut area once more, but we remember by using the replacement assistant, I already have reassigned 3 of them. I need those other faces as well. Just add them. Tension faces. There we go. I want to manufacture all of those faces. Say OK. Say once more OK. Right click, generate. There we go. That's the roughing now. And that's the finishing operation. So once more, roughing it and finishing it. All those settings are correct. Good. What else is not necessary? For instance, the finish outside operation. It's been this one here, no longer necessary. Right click and delete. I will make a regenerate around all the part.
Maybe that turn.
And the part, once more, is finished. We can start another simulation for that. Or maybe not just the simulation for this machine, maybe I want to use another machine. In my case, I don't want to use the DMG machine, and once more, I want to use a Hermle machine. For this, I am going into my library, select the Hermle that I want to have. I have to define the machine's position. I'm doing it by selecting a coordinate system. The system replaces the machine itself. And when the machine is replaced, like so, we can start the simulation again. Simulate the machine. The host processor begins to create a C code. In this case, it's going to be a Heidenhain controlled Hermle machine. The GMG machine in the first shot was actually a Siemens controlled machine. But with just a few clicks, we can rearrange every single settings. For instance, we just replace the fixture and we replace the machine just like now. Play. Well, that's actually it. The part is finished once more. And I see that I'm having also a violation in the Z-axis. That's something that the DMG would not have had. But okay, that's actually it. If you do have any questions of how we are accomplishing that, please do not hesitate to contact either AMS or Genius in the aftermath. Thank you for your attention. That's actually it.
Thank you so much, Henry. You continue to blow my mind. So just a quick
All
recap.
right.
Yeah, for Tim, you can take over.
Yeah. Well, that is some of the cool stuff that I've ever seen in NX, and I want to thank Henry again for joining us and being able to show us his black magic when it comes to NX automation. Of course, before we start the Q&A on this situation on this webinar, I'm just gonna run through some of the products and the services that we offer here at Chance Engineering. Of course, we offer NX CAD and CAM training to learn some of this, learn whether it's Technology Manager or CAM Setup or SpeedMill. We offer training for all of those. Of course, post processors and machine kits to virtualize your shop floor or your computer. Tool management systems like Technology Manager, SpeedMill, and we have SpeedWire as well to help automate multi-axis wire programming. So if you thought SpeedMill was easy to use or looked easy to use, SpeedWire is even easier to use than SpeedMill. We work directly in Teamcenter, so whether you're looking to manage your data within Teamcenter or looking to integrate into a DNC system such as ShopFloor Connect, we offer those services as well. And of course, on-machine probing and programming with kinematic correction, as well using Renishaw Productivity Plus, which directly integrates into NX. It's a very neat product that can help us actually make our machines more accurate and as well as measure parts at the machine. Process improvement, automatic shop documentations, and of course, customer-specific development.
Thank you so much for taking the time to join us for today's webinar. If you have any questions, feel free to leave them in the comments below or shoot us an email at theautomator@amscollective.com. And of course, reach out to us at that email to schedule a one-on-one automation consultation or to dive deeper into any of the technologies we've talked about today. Thank you so much for joining us, and we hope to see you again next month.